they give you the formula, and here's your formula right there for Newton's law of cooling. That says essentially you can put something in the refrigerator, eventually it'll reach the temperature in the refrigerator. Or you could put something on the countertop and eventually it will become the temperature of the room. If the temperature in the surrounding area remains constant, it will become the temperature of that wherever it's sitting. And that's part of forensics. They want to find out when somebody died. What did they do? They begin looking at the temperature of the body by taking liver temperature. But if somebody wants to go in and try to fool them, what they'll do is open up all the windows, turn on the air conditioning, or turn on the heat or something like that, so that the body temperature will change. And you can change essentially the time of death. Although they're getting much more sophisticated now than it used to be. But that's essentially, you could change the time of death, or they couldn't figure out what time. And then you'd have an alibi, right? Is what you would do. But I know none of you would want to go out and commit murder. At least I hope not. At least not me. I might give you a few people that, no, not really. Few former students, yeah. So anyway, it says Sophia's coffee maker brews coffee at 170 degrees Fahrenheit. Assuming that K is negative 0.024 and the temperature of Sophia's kitchen is 73 degrees, and then you're going to use a formula. I give you the information you need to use. You're going to use the formula to find the temperature of, it says, if she starts her coffee maker when she wakes up, how hot will the coffee be when she sits down for breakfast 10 minutes later? Well, if it's too hot, just put a dang ice cube in it, right? And if it's too cold, you throw it in a microwave, for goodness sakes. So if Sophia is worried, then she might want to just put her coffee maker on at a different time or have more control over her coffee maker. It's one of those kinds of problems. So the general formula they've given us is T of x equals T sub r, T sub 0 minus T sub r, e to the kx. Now what in the heck are all these stupid variables? Well, T sub r is the temperature of the room. So that makes sense. So all the T's are temperatures. T sub 0 is the initial temp. And K is the constant. And X is time, and in this case, in minutes. Anytime I have, oh, by the way, and then T of X, of course, is going to be the end temp. Anytime I have a formula, I'll list all the variables, and I've got to, if I'm going to have to solve something, I have to have values for everything except one. All the variables have to have a number except one. What always got me in trouble in physics, because if I had 5 variables, I could find 3 of the values. I needed one more, and I knew it had to be in that problem somewhere. So you reread the problem. The information was there. I had to discern it rather than have a numerical value, so it was telling me something. So I got myself in trouble that way. So the formula for our problem is, we've got the temperature of the room is 73 degrees. The initial temperature is 170 degrees. K is negative 0.024. So for our problem, the general formula is T sub x equals 73 plus, oh, come on, Peterson, times, I don't know where I got the plus. There's not a plus in this whole problem. Times,
Plus.
it is a plus. Okay, T sub 0, 170, minus T sub r, 73, e to the k, negative 0.024 times x, or T of x equals 73 plus 97 e to the negative 0.024x. Now, you give me a time, I will give you a temperature. You give me a temperature, I should be able to give you a time. And it says, if she starts her coffee maker when she wakes up, how hot will the coffee be when she sits down for breakfast 10 minutes later? They say X is 10, so they're giving me a time. So I'm looking for T of 10. It's 73 plus 97 e to the negative 0.024 times 10. And with my handy-dandy little calculator, I come up with 149.3 degrees Fahrenheit. Which undoubtedly is too hot for Sophie. Because she prefers her coffee at 130 degrees. Picky, picky, picky. And she's not going to just put an ice cube in her coffee like some normal human being would do, right? She's going to sit and wait and look at her coffee cup until it reaches 130 degrees. And then we begin to wonder about Sophia. If Sophia prefers a coffee at 130 degrees, how long will it cool? Again, this is not a problem that, because we haven't done logarithms yet, that they expect you to do by normal means. It says that 130 is going to be equal to 73 plus 97e to negative 0.024x. I'm going to subtract 73 from both sides, so 57 is 97e to the negative 0.024x. Divide by 97, 57 divided by 97 is e to the negative 0.024x. And then they expect you, which is approximately, by the way, 0.588. And then I played the same thing kind of game with my calculator. And actually what I did was, I put in my y equal menu e to the negative 0.024x, and I just graphed the sucker. I don't know what my window is. I am looking for a value of 0.558. So what I did is I just hit trace, and I just traced until I saw a Y value, and this just keeps going. I'm not sure where I am. I'm at 0.77. And use table same way. And I'm getting warmer. No, actually I'm getting cooler. And now we're getting better now. And you'd find it's around 22. About 22.1 minutes, about 22 minutes. And that's how I work that one. Now again, once we're through 5.5, you'll have an algebraic method of doing it. In fact, we'll have an algebraic method of doing it whenever we get to logarithms in the next section. And for those of you who remember from intermediate algebra, you could rewrite this thing as a natural log and do the same thing. So in other words, while this ends up being x is approximately 22 minutes, and that's using calculator. And if I rewrite as a log, for you remembering how to do logs, you would get that log base e of 0.55 or 588 is equal to negative 0.024x, and then you can solve for x using natural log. So x is equal to the natural log of 0.588 divided by negative 0.024. That's the way you would have done it in intermediate.